So I hope you made some progress and thought about my last question. Now, due to limited bandwidth, we need to be smart and not share everything with everyone. So there are four ways we can tackle this problem of V2X information sharing. Now, the first one is agent selection. So what is agent selection? It is nothing but to select like which vehicle to talk to. So we don't want to get information from everyone, as not everyone will know everything perfectly, right? So we can talk to those vehicles that actually know what we need, depending on uh, where we are in a urban environment. What is our location? So like if I want to see behind any truck in front of me, so what will I do? Suppose there is a truck over here, and I'm over here. So I want to sense this area, right? This area. So will I talk to a car that is behind me? But I don't think that because I don't think that would be the answer, because this car would also be seeing the same thing what this car is seeing. So obviously the correct answer would be to talk to some vehicle that is on this side, car B. So this vehicle will have all this information that is around this truck, right? And this is the crucial information that it can send to car A. So I will talk to someone who is on the other side of this truck and can see what is behind that truck and help me perceive it. Therefore, agent selection uses attention mechanism to figure out which vehicles are most relevant. So it gathers data from every vehicle and computes a matching score to determine the value of information, and only communicate with those vehicles whose information value is high. Now let me find some good papers over here that I can read later in all these approaches. So after going through this section, I'm interested in reading these papers. And then the first one is IUSI Corporate Perception, which is paper number 34. It's a 2023 paper. And this paper, it introduces the concept of importance of semantic information. So from both spatial and temporal dimensions, using a graph neural network to select the collaborators and fuse information from all those collaborators. So this is relevant to what occlusion. Now my second choice would be to read paper 35. So paper 35, it focuses on road geometry and the temporal dynamics of trajectories to understand how to prioritize vehicles based on the driving situation, like intersection or highway. So let me just write it down for my own understanding. And then my third paper would be, I won't go overboard because the literature survey has shared so many papers, but I'm just targeting 2 to 3 papers, not more than that, to better understand this topic. So I'll also read paper 32, which is mass 2023 paper. So paper 32, it solves the collaborator selector problem using restless multi-arm bandit. So multi-arm bandit. So it is interesting because it accounts for high mobility of vehicles, and so I can learn how to make scheduling decisions in a dynamic environment. Second technique is information selection. This means that choose what data to share. So in the information selection, we can use rule-based approach or distance-based approach or machine learning-based approach to determine the most crucial information. So for this one, I will read the papers 53, 43, and 49, 53, which introduces spatial confidence maps to identify perceptually critical regions, enabling agents to share only spatially sparse but crucial features. And then my next choice would be paper 43. So this basically addresses how to selectively share the most critical multimodal feature. So like from different sensor types like camera and lidar, so across agents using a preferred threshold mask. So this is highly relevant for heterogeneous fleets where vehicles may have different sensor suites. And my third choice would be paper 49. What paper 49 does, it solves a local optimization problem. So this is to determine which spatial regions should be prioritized for transmission based on an information score map. And then third one is agent selection and also information selection. So you must have already understood that this is like choosing both who and what. So for this one, I'll read paper 53. They have only mentioned there's only one paper, that is 53. So I will read that and also check if that is the only paper that has worked on this. And the fourth one that they mentioned is information compression. Basically means like shrinking the data before sending to all the vehicles that are in its vicinity. So these methods, they compress or decode features before sharing. So for this, I will read these papers. My choices are like paper 58, which is DiscoNet, and then paper 61 and 65. So this one is Center Coop and this one is Smart Coop. Paper 58, it proposes the knowledge distillation to train a student model to mimic a more powerful teacher model. Whereas 61, Center Coop, it introduces a communication aware regularization. And paper 65, it addresses the key gap that most compression methods apply some ratio to all agents. And that will be a problem in some dynamic cases, right? So they propose a learnable encoder to dynamically adjust this compression ratio based on channel state information. So the next subsections in this paper, they cover V2X communication technologies like DSRC, CV2X, and I have already covered those in my previous video, so I will skip that for now. And so as I have a gist of these topics already, now what I'm going to do is I'm going to go totally out of script, and I'll do something that is very different. So rather than going deeper into this literature survey anymore, I'm going to go deeper into the agent selection section, this part. So agent selection section. So let's see if I can, quickly cover other authors' work in the on this technique, paper 34, 35, 32, and I might, read more papers on this technique and find a research gap that I can address. That would be my next goal. I'll go totally out of script now. And so far, I have only been reading what other researchers have done. Now I'm going to, so after that, I'm going to, stop for a moment and see if I can find something that haven't solved yet. Thank you.